Alright, in this video we're going to show you how to create a motion study. For this example we are going to use a toy helicopter. I've already mated the propellers to the main body, however I have not constrained the rotation because we will want to create a motion for that later. We want to start off by mating the default planes of the helicopter to the default planes of our assembly. For the front plane, since we're not going to change any dimension in that plane, we can constrain those two planes with a coincidence mate. Because we want to rotate the helicopter while it's in the air, we want to mate the origin of the helicopter to the default planes, both to the top and to the right plane. Now we can control the position, so we want to add another mate here to control the angle. Because this value is going to change in our motion, we want to apply a 0-degree angle mate. So because we want to change our position, we want to change our coincident mates of our origin mates to a distance mate, as I'm doing here. This will allow us to change that mate as we animate. Alright, now we want to open up our motion study tab and drop down our mates. These are the values that we're going to change. Before we change the mates, however, we want to add a motor to our propeller. That can be done by selecting the motor button here. First of all, selecting our propeller as our body we want to rotate, and the helicopter body as our fixed body. Next, we want to select segments as our motion type. This will pop up a dialog box. We want to change our velocity, or our value to velocity, and insert a new segment. The first segment is going to be a ramp-up segment, so this will take the propeller from 0 to 360 degrees per second. We want this to occur over the first 5 seconds of our motion. Next, we will add another segment, and this will just be a constant 360 degrees per second motion. For the segment type, we want the segment at the beginning to be cubic. That gives us a nice smooth acceleration. The segment type for the constant part isn't crucial. However, we can select linear from the drop-down menu here. That will give us a nice smooth motion. And just select yes to apply that. In that dialog box, we selected 12 seconds as the length for our animation, so we can click and drag our top key there to 12 seconds to give us our total time frame. Now we want to add the hover motion. So we place a key to symbolize a point where a value will start to change, and we will place another key by right-clicking, selecting place key, to symbolize the end of our motion. We can click and drag that to any time we want. As you can see, by hovering over the key, it shows the value of the mate. So we want it to start off at 0 millimeters above the surface. For the second point, we want to double-click and change that value to 1,000 millimeters. If we hit rebuild, we can see that the helicopter now lifts off the pad. That's exactly what we want. Once you click OK, you'll see a blue bar that symbolizes that a mate is changing over that point. We can now right-click on this end point of the motion and select interpolation mode. The default is linear, which does not give us very realistic motion. For our case, ease in, ease out is probably our best bet. As you can see, we now have our endpoint at 1,000 millimeters with the ease in, ease out interpolation method. Now we want to add an angle to our helicopter. This can be done again by placing keys for the start and end points. Again, click and drag till you're happy with the time frame you want. Double click the second point to add your end angle. Here we're going to use 10 degrees. And if you rebuild, you notice it tilts up. That's not what we want. We want it to tilt forward. And because the SolidWorks motion study does not allow us to use a negative value, we need to go back to our model view, select the angle mate, and flip the dimension. Now if we double click this mate again and rebuild, it now turns the correct way. Now we are adding the motion for the helicopter to fly forward. This can be done the same way that we did the hovering motion, adding 2 keys and again selecting a value for the distance we wanted to travel. Now once all your mates are in, select calculate and it will create your motion study. As you can see here we get a pretty good motion of the helicopter flying up and off the screen. We're just going to add another motor to the rear propeller. This is done in the same method as the top propeller. So another feature that we can add is the ability to change our view, our camera angle. So we can do this by switching to our model view, finding a camera view you're happy with, pressing spacebar, and selecting a new view. Give this view a name, and select OK. This can also be done by right-clicking and selecting View Orientation. Switch back to the Motion Study tab, go to the Orientation item, and add a new key point for the end. Right-click each key and add your view orientations. In our case, start for the beginning, end for the end. SolidWorks will then interpolate between each point, linear, Zoc, and OK method for that. As we can see by calculating, the camera now pans as the video progresses, gives us a more dynamic motion study. Once you are happy with your video, you can go to Save Animation. SolidWorks gives you several options. You can change your aspect ratio, whether it's your screen size or some other custom ratio. SolidWorks also provides their own renderer, however, there are other options that you may use. Thanks for watching.